All right, so this is an excerpt taken from the Bristol Aerospace Limited book celebrating 75 years of technology. Volume 3, 1930, from 1930 to 2005, specifically the CRV section. Defense Program. The Canadian Air Force began converting its CF 104 squadron in Europe to a primary ground attack role with a conventional armament in 1970. The folding fin aerial rocket, the FFAR, was a common air to ground weapon for fighter aircraft in that role and formed part of the initial weapons stock of the Royal Canadian Air Force squadrons. There were problems associated with this item, and a requirement for an improved 2.75-inch rocket was stated formally by the Canadian Forces in 1971. Sponsored by Department of National Defense and the Def- Defense Research Establishment Valcartier and Bristol, in very close cooperation, kicked off a program to develop a superior 2.75-inch rocket motor, to be called the CRV C14. The development program involved significant participation by industry, and from 1973 to 1983 saw an approximately 20 engineering man years seconded from Bristol to DREV and D&D. The first air launch test of the C-14 prototype motor occurred at Cold Lake, Alberta in July of 1973. In 1976, Design Authority (DA) in Department of National Defense approved full-scale production of the CRV7 C-14 motor. The C-14 motor used a modern composite propellant and wraparound fins. It had a vastly improved performance compared to existing FFAR. Launchers were modified to accommodate the shear pin retention system of the new rocket, and reliability and safety, as well as performance, were significantly enhanced. A couple of years later, the CF 104 starfighters in Europe began to use the CRV 7 in weapons training sorties at various ranges in Europe. Note that the affiliation of the Canadian squadrons with other NATO squadrons was very strong and close, with combined exercises and operations being the norm. On the weapons range, a four-plane flight of CF 104s would be entering at their scheduled range time as another nation's flight was departing at the end of theirs. Initially, the Canadian pilots fired rockets on these ranges at the same parameters as they had fired the FFARs. With a much longer burn time, the C-14s were still burning and accelerating at ground impact. The resulting flash and column of dirt kicked into the air gave the perception that the pilots were using live warheads, which were prohibited on some training ranges. More than one flight of CF 104s were kicked off the range due to this misrepresentation. The pilots soon increased their range for firing the rockets, but increased accuracy of the CV-7 resulted in extensive target damage. This meant that the range had to be closed while targets were repaired. Eventually, Canadian squadrons were limited to late Friday afternoon firings, so that targets could be repaired on the weekend. Word about the CRV-7 soon spread through all NATO air forces flying in Europe, including the United States Air National Guard, on their deployments, and it was regarded highly. Soon there were serious queries from several air forces about the CRV-7, and the operators were scheming as to how to get the weapon cleared on their aircraft. Compatibility work done by the U.S. Naval Air Testing Center on several of their aircraft for NATO cross certification and interceptability led to the clearance of the A7 in March of 1980, and others, including the A4. Later, Bristol's first export sale was in 1981 to Portugal for use on their A7s. Germany began a clearance program on the Alpha Jet. An agreement was concluded with Raufoss in Norway for a licensed CRV7 C14 production for Norway and Denmark, and the installation of production capabilities began in 1980. In 1990, the RAF joined the fold in preparation for the first Gulf War. In other parts of the world, the CRV7 beat out the competition in the late 1979 in Malaysia, working through the Canadian Commercial Corporation, the Triple C. The largest single contract up to that time in Bristol's history was signed with Malaysia in 1980. In 1981, deliveries began. Word of the superior performance of the CRV7 spread through the region, with the results that Singapore became a customer by 1983 and Thailand by 1989. After their own clearance program, the Royal New Zealand Air Force became a customer by 1983. Finally, today, the CRV7 has exported to the governments of 12 countries, including Portugal, Malaysia, New Zealand, Norway, Denmark, Singapore, Thailand, Oman, United Kingdom, Czech Republic, Australia, and Botswana. C-15 development. There was a desire to replace the FFAR rocket on its helicopters as well. Unfortunately, the C-14 rocket motor had an aluminum in the propellant and produced a dense white smoke trail during its more than 2-second burn time. To fire even a single rocket from a helicopter was the risk of losing all visual reference for flight. Fighter aircraft operations could also benefit from the reduced smoke motor, as the C-14 smoke trail immediately indicated the aircraft's presence in the targeted area. In 1977, D&D initiated a program to develop a reduced smoke 2.75-inch rocket motor to replace the C-14, called the C-15. The design, development, and testing and evaluation of the C-15 rocket were conducted under a Bristol-DREV joint program. The first move was to remove the aluminum from the propellant. Much development was required to come up with the propellant that came close to the C-14's propellant for total impulse and that exhibited all the other essential characteristics, such as stability, ignition, reliability. In 1984, after exhaustive series of qualification tests, the C-15 rocket motor was approved for full-scale production by D&D. The C-15 motor had a much reduced primary smoke signature. Note the photo of the C-5 simultaneously firing C-14s from the right wing and C-15s from the left wing. The new motor had practically the same ballistics as the C-14 motor for the rocket's firing ranges used by fixed-wing fighters, with only marginally less energy. Note that the C-15 still has almost double the energy of the old FFAR motors. Because the exhaust efflux is much less abrasive and cooler, training launchers lasted longer. Aside from satisfying the initial helicopter requirements, the C-15 quickly became the preferred motor of fixed-wing fighters. C-15 improvements, the C-16, the USN foreign comparative tests. For Bristol, 1987 was a busy year for the CRV7 folks at Bristol. I should have just said that. With coordination between major players, the following 3 events occurred practically simultaneously. Bristol initiated a product improvement program to develop a variant of the C-15 rocket motor that would interface with the launcher system currently used by the U.S. Navy. This required a new nozzle design. The resultant C-16 rocket motor was otherwise identical to the C-15 rocket motor. In May, the U.S. Navy Air Systems Command submitted a candidate nomination proposal to perform a foreign weapons evaluation on the C-16 rocket motor, and it was approved. Bristol also initiated development of the C-15 head-end permanent igniter rocket motor as an upgrade to the existing C-15 rocket design, which had an igniter in the nozzle throat. Several rocket improvements were incorporated at the same time. In April 1988, the USN received the funding for the FWE as a foreign competitive test. Bristol received a contract to supply 1,000 C-16 motors and delivered these to the USN by June of 1989. By then, there was a shift to the FCT objectives. The Advanced Rocket System, ARS, operational requirements to replace all 5 and 2.75-inch rockets in the USN was approved, and the FCT and the FCT would be performed on the C-16 in support of the ARS requirements. FCT testing was completed by 1991, and the analysis was complete by June. The C-16 had done quite well compared to the requirements of the ARS. It's almost met the intense munitions requirements of the US Hydra 70 rocket was a clear failure. And it met all the performance requirements except for, just turn the page here, except for dispersion from a helicopter launcher. It met the elastic discharge ESD and the hazardous electromagnetic radiation ordnance HERO requirements, except for during unauthorized loading procedures. More development was required to fully satisfy the ARS requirements. Bristol now focused on the ARS program and intensified efforts towards the development of an optimized CR7 rocket motor for helicopters. This motor, to be called the C-17, probably would have resolved the major deficiencies in meeting the ARS requirements. Unfortunately, the ARS requirements was cancelled by the time the C-17 was qualified and available. The C-15 HEPI rocket motor was fully qualified and approved for full-scale production by D&D in 1994, following the C-17 motor in 1995. UKAH program. In April of 1996, Bristol won its largest CRV7 contract to supply the CRV7 RWS for the United Kingdom Attack Helicopter UKAH program. By the end of May 1996, Phase 1 of the firing qualifications was underway at Yuma, Arizona, funded by Bristol and Boeing, with the objective of verifying the operational compatibility of the CRV C-17 RWS with the U.S. Army Longbow Apache and safe launching clearances. 667 C-17 rockets were fired. The trial comprised of 28 missions and took 2 weeks, proving system airworthiness on the AH-64D and paving the way for follow-on UK Ministry of Defence trials. Rockets were fired with a helicopter variously in ground effect, hovering out of ground effect, flying sideways at several speeds, flying forward at up to 120 knots, and even flying backward at 45 knots. In addition, Bristol conducted trials at Suffield, Alberta, Great Salt Lake, Utah, and Terra, New Mexico during the summer months to demonstrate that the C-17 motor would function with all the new warheads involved in the UK program. In November of 1996, Phase 2 of the firing qualifications were completed successfully on the AH-64D, again at Yuma. GKN Westland Helicopters Limited and Boeing funded the qualifications. Of the 907 rockets fired, 801 were air-launched. The primary objective of the phase was to verify the CRV7 C-17 ballistics coefficients through accuracy tests, as well as to conduct envelope expansion tests for rocket firing. Results were excellent. The rockets delivered on average in firing conditions from hover to 90 knots airspeed, approximately 40% better accuracy than the US Hydra 70 Mark 66 rockets. Ballistic software in the Apache fire control system required minor modifications. The UKAH contract included the general-purpose Flechette warhead, which was still in development in April of 1996. The completion of the development and qualifications and the productionization was transferred to the Royal Ordnance, RO, as part of the UCA program. The warhead was specifically designed for use with the CRV C-17 rocket motor to defeat the light armored targets and attack helicopters. It consisted of a casing, a fuse, a payload of a flechette rack, and 80 tungsten flechettes. The mechanical pyrotechnic fuse is armed by sustained high acceleration and functions when the acceleration diminishes at motor burnout. At that point, the flechette rack is expelled from the warhead case, and warhead spin shreds the covers and disperses the flechettes. The flechettes fly to the target and do not tumble. Development of the warhead with RO was an intensive affair in design changes of both the rack and the flechettes. The warhead functions at almost 3 times the speed of sound after undergoing significant sustained G-forces. First air firings with the UK Apache Mark I during the Phase 3 trials were impressive. Of the 1,886 rockets fired at Yuma, 1,880 were air-launched, and all objectives were attained with satisfactory results. On the 30th of November 2001, the final all-up round assembly specified in the production phase of the 1996 contract was completed. It was accepted by the UK MOD, Ministry of Defence, the following week. In addition, the final design review of RPD was held on the 14th of February 2002 in UK during which the UK MOD provided the production go-ahead for the RPD. A CRV7 training clearance occurred 2 months later. During Phase 3, debris ejected from the C-17 motor caused a superficial damage to the tailplane of the testing aircraft. By the end of 2003, Bristol had engaged the program, changed the design to eliminate most of the debris, and had tested the qualified change. The reduced debris motor is now the C-17 production standard. The CRV7 is a highly successful program for Bristol in Canada. Some of the key players in CRV7 program during the last 25 years were John Baird, Bill Vaught. It just goes on to name the folks. But that's the CRV7 rocket motor history for Bristol Aerospace.